Let's discuss the shortcut method to solve the exact equation. And you know that when you want to solve the exact equation, it needs like 8 steps. So here we can do it quickly, we using like only 3 steps. So let's see how it works. So the idea is this: we start with the equation. First, as in the other method, we first need to check whether it's exact. So let's do that. So if the partial derivative with respect to y of m equal partial derivative with respect to x of n equal, they are equal, then we know that is exact. So that means there is a function fxy such that it gives the partial derivatives. The x partial derivative with this, gives the m function. The x1 gives the m function, and the y derivative gives the n function. So that's by the definition. That's what we call exact equation. And then what we do now, we integrate them term by separately. You integrate the first one by x, the second one by y. So integrate separately. From the first one we get this. So you will get some expression of x and y, and you integrate with respect to partial integrate with respect to x, keeping y fixed. Now do the same thing with the other one. So you integrate partially with respect to y, so you get another expression. So now the answer is this. So then the fxy equal, first we take the common term. So we look at the both expressions. So we look at both expressions and write common terms once. You write the common terms once, and then you write uncommon terms once. So you write the common terms once and the uncommon terms once, and this is going to give the fxy function. And then what we do, we set this one equal to a constant, and that's going to give you the implicit solution of y. So that's the idea. So let's look at a few examples and see how quickly we can get the answer. And also you can find the link in the description if you need more examples like this. So you can find this problem in the ZIL differential equation book, and let's see how we can use a shortcut to get the answer quickly, just for comparison purposes. So as before, we identify the m function and the n function, and then we can check the condition. So you can see the two partial derivatives are equals to 2x, so it is exact. So that means there is a function fxy such that the partial derivative with respect to x equal m function 2xy, and partial with respect to y equal to n function x squared minus 1. Now what we do, we integrate them separately, and we get x squared times y plus some terms. So we can just write 3 dots, and then if you have from the second one, that is with respect to y, so you get x squared y minus y and some terms. So now we pick the common one and the uncommon one, and you can clearly see that that's the common term, so we write once, and then this is the uncommon term, we write that one also once. So then fxy is, so we write the common term once, so it is x squared y, and then minus the uncommon term, which is minus y. So we just set this one equal to a constant. So that is the implicit solution of y. And then actually you can see that in this case you can solve for y. So y equal, you get, if you divide, you can get c over x squared minus 1. So that is the complete solution for this problem, and you can see this solution is defined when x not equal to plus or minus 1. So you can see that this is how you can solve the exact equation very quickly using a shortcut method. So let's look at 2 more examples. Next, we look at this problem from the same book for comparison purposes, and you can see again we're going to pick this one as m and the other function as n, and then we check the condition using the chain rule. So first there's the first term is 2e 2y, the second one you have to use the product rule. So if you use the product rule, which is the derivative of the first term, so you get y, and then you get the cosine xy, and then you get minus y times, and you can see it's a cosine, so cosine becomes negative sign, so it becomes plus, sine xy, and also you need to multiply by the derivative of the inside function. But here remember x is a constant, so you're gonna so you get the x term comes out. Okay, so that's the derivative, and then you can see that if you take the derivative of the n term with respect to x, and you see that you get the same thing. So they are equal, so that means exact. So then there's a function f x y such that da by f over da by x equals the m function, da by f over da by n, da by f over da by y, da by f over da by y equal the n function. Now integrating separately, first with x, next with y, we get these two. So the first term is clear, is x e to y. But what about the second one? Second one, you have cosine xy, that means you have to start with sine term. Since this is a partial integration, you can see the y comes out as a function. So that means it has to be sine xy. If you take the partial derivative, you get the function we have here. And then plus some terms, we just put it like that. And then similarly from the other one, so we get the first two terms as before, and also we have a 2y, that means you get y squared extra term, so plus 3 dots. Okay, now we write the common and uncommon terms, and you can see these two common and these also common, so we write them once, and then we write the uncommon term, which is y squared, once. Finally, we set this one equal to c. This is going to give you the implicit solution for y. Okay, so this is how you can solve a exact equation using a shortcut method, and just compare. If you want to do this using the regular technique, it's really long because of the expressions we have here. But this method, like, not that bad, and you can get the answer much quickly. So let's do one last problem from the same book. Solve the following differential equation if possible. Here we try to focus on the exact equation technique. So see whether you can use the exact equation method, either with a method, either long method or the shortcut method, and also check whether this is exact first, and you have to bring it to the right form first, and then you need to check the condition, and then use one of the methods to solve it. And if you have any comments, you can put them in the comment below. Thank you so much for watching.